Welcome. In this video we're going to talk about what we call multiplying a vector by a scalar or by a number. So it's a scalar multiple. Or you could say multiplication of a vector by a scalar, but we want to save a little bit of time. So suppose you had a scalar and number. Let's call this number c. It could be 1, it could be 10, it could be 0 point something. And now this number is multiplying a vector. This thing here has the sense of direction. This is just something that only has magnitude, whilst v bar has a sense of direction and magnitude. So how do you multiply these two things? What's the proper way of multiplying them? Well, remember, now that we know how to represent vectors in unit vector notation, in principle we can always write vector v, in unit vector notation. So if we were to write vector v in unit vector notation, it would have an x component, which we represent by v sub x in the I hat, and it will also have a y component in the y direction, and so also with the z, that will be in the k hat direction. So now, when we multiply this vector by a number, a scalar, what do we obtain? Well, the way you multiply a vector by a scalar is that the scalar multiplies each of the components of the vector. So that means we're going to have c multiplying v sub x in the I hat plus c multiplying the vy in the j hat direction plus c multiplying vz in the k hat direction. So whenever we multiply a vector by a number or by a scalar, the scalar multiplies each one of the components. It distributes through. If you like, you could think of it as c is foiling through each of the components, if that helps you to remember it. So let's bring our vector. What was our old vector? 2, 3, and minus 4. So let's suppose we had vector A 2, 3, and minus 4 k hat. Suppose we were to take c, the number, to be equals to 2. Now we are interested in calculating what is c times a bar. Well, c is equals to 2 times a bar. That means this 2 needs to multiply each of the individual components of vector A, and let's do exactly that. What is 2 multiplying the x component? That's going to be 4 I hat. And what is 2 multiplying 3? That's going to be 6. But that 6 is in the j hat direction because it's the y component. And finally, what is 2 multiplying minus 4? That's going to be minus 8. Obviously, this minus 8 is in the k hat direction. So, when we multiply a vector by a number, we obtain another vector, except its components have been doubled in this case, or have been multiplied by the scalar. So this is how we multiply a vector with a scalar, with a number. So in the next video, we will be able to talk about what is the effect of this kind of a multiplication. Actually, we could talk about it right now. What is the effect of this multiplication? Let's try to calculate the magnitude of this vector. Of this vector, and compare it with the magnitude of that vector. So for that, I'm going to copy these guys to the next page, and then we'll have more space. So let's paste them over here. Now, let's calculate the magnitude of vector A. Well, the magnitude of vector A is basically going to be the square of each of its components under a square root. So the sum of its square, the sum of the square of its components and rooted. So this is going to be the square root of 2 squared plus 3 squared plus negative 4 squared and that will all be under this square root. So that's going to be what? 4 plus 9 plus 16. So this is going to be 29. Yes. Right. 29. Now let's do the same for this vector, the vector that has been multiplied by 2. The same vector A, which now has been multiplied by vector 2. Let's go ahead. So the magnitude of CA bar is going to be equals to the square root of 4 squared plus 6 squared plus negative 8 squared. When you run this calculation, you will realize that this is 2 root 29. Notice what has happened. We have multiplied this vector, A, by 2. Its magnitude was initially 29, but since we've multiplied by 2, now its magnitude is 2 times root 29. I'm sorry, its magnitude was root 29, not 29. It was root of 29. And now that we've multiplied by 2, its new magnitude is 2 root 29. So whenever you multiply a vector by a number, that number rescales the vector. So if the area representing vector A was, let's say, 3 centimeters long, the area that represents this vector, 2A bar, would be twice as long, so it will be 6 centimeters. The point is, multiplying a vector by a scalar actually rescales. It changes the magnitude of the vector. I should emphasize that it doesn't change the direction. For as long as this C is positive, the direction of the vector is unaffected. However, if the C is negative, not only will the magnitude of the vector be affected, but so also will its direction, because these components will acquire a minus sign overall, or will be multiplied by a minus. As a result, the orientation of the vector would also need to change. So this is the effect of multiplying a vector by a scalar, is that it primarily changes the magnitude of the vector, provided that the scalar is positive. And if the scalar is negative, it will change both the magnitude and the direction of the vector. I think we should conclude this video here, and next we will talk about how vectors can be multiplied with one another. Okay, see you in the next video.